About a few more definitions, critical numbers and how they relate to extrema. So we need to understand what a critical number is first. So if f of c is a relative extrema for some function f, then c, so the location where the extrema happens, remember this is the x value, is a critical number of f. That is of f, that's not off, just so you know. So given f of c is defined, C is a critical number if, these are the two scenarios on what makes something a critical number, f prime of C equals 0, so the derivative at C is 0, or f is not differentiable at C. That doesn't mean that we can't take the derivative of the function, remember. It just means that derivative doesn't exist at C. That's another way to say that. So f prime of C does not exist. So an example of that would be if a place where the denominator of the derivative equals 0, potentially. So the absolute max and absolute min of f on the closed interval AB occur either at an endpoint of AB, so either at A or at B, or at a critical number within the interval AB. So way to sum that up, critical numbers are where relative extrema will occur. Just because we have a critical number doesn't mean a relative extrema will occur there, but a relative extrema can only occur at a critical number. And that's where an absolute extrema can occur as well if it's within the open interval. Absolute extrema, remember, can also occur at an endpoint. So here are some examples of what we're talking about. If I have this curve here, and I can say that this is a closed interval. So I have a closed interval from this location A to this location right here, and the graph just stops. So this is a closed interval. So I have an absolute minimum here at A, and it's an absolute minimum because that is the lowest point on the graph. It is not a relative minimum because A is also an endpoint. Here I have a relative maximum. It's not an absolute maximum because it's not the highest point, but it's relative. Now also notice this is a sharp turn, so this would be a place where the function is not differentiable, but that would still give us a critical number. Here we have a relative minimum at C. Here I have an absolute and a relative maximum at D. So it's the highest point on the graph, but it's also a maximum point within an open interval. Okay, so again, absolute maximum minimum is the highest or lowest point on a graph. It can be on an open interval or a closed interval. A relative maximum or minimum is the highest or lowest point on an open interval. Critical values are inputs where the derivative is 0 or does not exist, and critical values are the potential locations of extrema. When we're talking about extrema, we're talking about maximums or minimums, which are also turning points.